Good evening. All right, that we are on and ready. Welcome to another night of live math help, free live math help. If you have a math question that you would like for me to do online tonight or on the live tonight, please text me at 407-801-9255. I am here. I'll probably be here for an hour, probably less if I run out of the material that I plan to go over tonight. But tonight, our focus, if no one texts me, is going to be 6th grade math, and then we'll venture on into some 7th grade math. So, let's see here. Give me a moment. Okay. All right. I am here. I am available for you. If you need some help, you can text me again at 407-801-9255. Okay, let's get started. Let's do some 6th grade math tonight. All right. So our first equation, our first math problem says, it says an equation is shown x plus 14 is equal, x plus 5 is equal to 14. Which of the values can be substituted for x to make the equation true? So, if you know how to add, you know how to do this problem. So, but some kids have issues. So, one thing I like to do is explore each answer choice and to tell a kid or a student, or even an adult, why a question is, why an answer is right and why one is not right. So I'm going to go ahead and say the answer is going to be B, but here is why. So for answer choice A, 7 plus 5 gets me 12, so it won't be A. For answer choice C, 14 plus 5 gets me 19, so it won't be that one. And for D, 15 plus 5 gets me 20, so it won't be that. So you have to let people know, or students, or anyone who needs to know, why an answer is the only answer possible, and why the other ones are not possible. Okay? Let's keep going. So for the next question, it says, an inequality is shown 2 over 7 times n is greater than 4 over 3, or 4/3. So select all the values of n that make the inequality true. So what you can do here is you have to actually, I would go and solve the problem first, and then I would go and look at the answer choices. So to solve this problem, you would have to multiply both sides by the reciprocal of 27 over 7. So let me rewrite this question. So we have 27 over 7, and it's greater than 4/3. So I want to multiply both sides by the reciprocal, and that's going to be 7 over 27. And I did say reciprocal. This is the word I am saying. All right, on the left-hand side, they cancel out to equal for 1n or n, and that's going to be greater than or equal to 28 over 81. Okay, so now at this point we need to figure out, well, which one of the answer choices should I pick to be a part of the values that I can use for n. So any value that I select has to be greater than 28 over 81. So I could, right off the bat, I already know that this is a fraction, and so I know I could pick C. Because C written as a fraction, equivalent, well, with the same denominator as that, would be 81 over 81. Okay? So let's look at some other ones. This is when you need to know your number line stuff. So let's see. If I was to put this on a number line, well, let's do the easy ones first. Let's look at 1/3. The reason I'm picking 1/3 is because I can make 1/3 have a 81 as a denominator. So what number can I multiply 3 by to get 81? And I do know that that is 27. And so if I multiply my denominator by 27, I need to multiply my numerator by 27. So 1 times 27 is going to give me 27. So I already know that this number here, 27 over 81, is less than 28 over 81. So I'm not going to pick that as one of my answer choices. So let's eliminate answer choice B. Now let's go look at answer choice D, because I do know that the denominator of 9 is a factor of 81. So let's take 2 over 9 and let's change that to have a denominator of 81. So what we're making here are equivalent fractions. So 9 times 9 gets me 81, and 2 times 9 gets me 18. Well, 18 is less than 28, so I want numbers that are greater than 28 over 81. So this would not be a good choice as well. So we can eliminate that. Now let's go to the ones that are a little bit harder to actually see. So let's put it on a number line. I guess we can see a little bit better. So if I was to draw a number line, let me erase some stuff. I have some room. Okay, so if I was to draw a number line, like this, and I want to put 28 over 81 on the number line. So over here I have 0, or 0 over 81, and over here I have 81 over 81, which is the same thing as 1. So that's why I picked 1. The halfway point here would be 40.5, if this makes any sense, over 81, because that's half of 81. So where would the 28 be? The 28 would be here. You know, just somewhere in between. 28 over 81. What else do I know? Let's look at the 3 over 2. The 3 over 2 is an improper fraction. This is improper. This is an improper fraction. So this is really 1 and 1/2. Well, is that going to be bigger than 28 over 81? Absolutely. Because 28 over 81 is here, and 1 and 1/2 continues on over here. So 3 over 2 is going to be greater than 1. So I can pick this one as one of my answer choices as well. Now, let's talk about 2 over 5. If we had another number line and we're talking about the halfway point. If this one was 0/5 and this was 5/5, then my halfway point would be 2.5/5. Well, 2.5/5 is going to be here, 2/5. But is this greater than 28/81? It's not going to be that as well. So what I could do is multiply this number here to make sure I can say 27/7 times 2/5. And it has to be greater than 4/3, really. So this is going to be 54/35. And will that make it the value greater? Yes, it would. So we will pick that. Let's go to the next one. All right, next question. It says an equation is shown 8x is equal to 35. What is the value of x that makes the equation true? So with this, we have to divide both sides by 8. So this is 8x is equal to 35. Divide both sides by 8. 8 is going to be 35/8. Now, depending on how they want the answer written, you could possibly just leave it like this. Or if they wanted a mixed number, you could write it as, let's do division, 35. This is going to be 4, 32, and 3. So this would be 4. Remember, this is your whole number. And this would be your numerator. And this would be your denominator. Okay, so the answer here is going to be 4 and 3/8 if we wrote it as a mixed number. So we could have both of these answers here. Alright, let's go to another question. For this question here, it says, Susie buys a salad for $6.35 on lunch. I think that's supposed to be, yeah, I think it's supposed to be stems. I think it's supposed to be stems. I didn't type this, y'all. So Susie spends $6.35 on lunch. That makes more sense to me. She bought a salad for $5.12 and a drink for X dollars. Which equation can be used to solve for the price of the drink? Alright, so what we could do is just look at each answer choice. Well, first off, let's just make the equation ourselves. We know that when we say and, in this particular case, we're kind of adding. So if we know we add, and we can eliminate answer choice A and B. So let's look at it. She bought a salad for $5.12, and she bought a drink for whatever amount of money, and she spent $6.35. So the only answer choice here would be C. Okay, let's keep it going. Next question says, a graph of Evan's bank is shown. So it says fill in the bubbles to select the dependent and independent variables. Well, when you're looking at a graph, your independent variable is always going to be on your x-axis. So this is my independent variable. And my dependent variable would be the account balance. So let's label that as dependent variable. So we go ahead over here and make our choices. So the weeks would be our independent variable, and our dependent variable would be the account balance. All right, let's keep going. That one wasn't too bad. So for the next question, it says a shape is shown, and it's not to scale. It says, what is the area in square inches of the shape? So to do this type of problem, you would need to break this shape up into pieces, into something that you would recognize. So the shapes that I do recognize in here, or everyone should recognize, is the shape of a rectangle. So it's up to you how you want to break it up. I'm going to break it up like this here. I'm going to break it up like this. And I'm going to label my pieces. So I know over here from this top to bottom, and let me just make this whole rectangle red. So for the red rectangle, this is going to be 2 inches as well. And then from left to right, I know I have 4 plus the 2 inches here, so it's going to be 6 inches. So the area of the red rectangle is going to be area equals length times the width, and so it's going to be 2 times 6, or 6 times 2. So this area will equal 12 square inches. Now let's make the other one a different color. So let's make this one yellow. And let's label the pieces here, which is pretty much already labeled. So one side is 3, the other side is 2. So the area of the yellow rectangle, hi P, you want to join me? Okay, that's fine. Area equals length times the width. So this area is going to be 3 times 2, and it's going to be 6 square inches. So the total area of the shape will be 12 in square inches plus 6 square inches, and it's going to be 18 square inches. Stop whispering. What? It's okay, you can talk. What do you want to say? What do you want to say?
Nothing.
You want to say anything?
No.
All right. Huh? Stop being weird. Oh, I'm not telling you.
Tell me.
Okay, so it says here, a pentagon with dimensions in inches is shown. And so we have this pentagon. They already have it broken up into different shapes for us. It says, what is the area in square inches of the pentagon? When you look at this problem here, it looks intimidating. Very, very intimidating. But with this type of problem, you have to take your time and take it in pieces. So let's start with the triangles. I'm going to start with these two triangles here because they're both the same. Well, I'll just mark one of them for now. So the area of a triangle is A equals 1/2 the base times the height. So you have 1/2, and the base is, in this case, it's going to be 4 because we have this portion right here. All right, so let me explain this a little bit better. Let me draw it to the side. Right here. Let's take it out of the picture and draw it. So we have 4 inches here, yes? And then this, the hypotenuse, is the slanted portion, so we don't need that part right there. But the base, which is, or on one of the sides, this side to here, we have to figure that out. So if I'm looking from here to here, it's going to be 2. And from here to here, it's going to be 1. So this is going to be 3 inches. Okay? So if that's 3 inches, then I need to multiply this by saying the base of 4, the height of 3, or it could be vice versa. It really doesn't matter. So for this triangle, it's going to be 1/2 times 12, and then I get 12 over 2, which is going to be 6. And so far, this is 6 square inches. And then because this triangle has the same dimensions, this one up here, it's going to be 6 square inches. All right, so now let's keep going. Now let's do the triangles to the side. Let's do these two. So the area of these triangles, the green ones. So the shape looks like this. And this is 1 inch. And from top to bottom, it's going to be 5 inches. Now, where did we get that from? Let me erase a little bit in the middle. It says it here that it's 5 inches. So this area is going to be A equals 1/2 1 times 5, and that's going to get you, you know, all of these are all fractions. So you go 1 times 1 times 5 is 5, and 2 times 1 times 2 is 2 times 1 times 1 is 2. So this area would be 2.5 square inches. So that 2.5 is going to go here and here. Alright, so the last thing to do is the rectangle in the middle. So let's do this part here in the middle. And so let's label it area of the rectangle. Area of the rectangle. And it is length times the width. And this is going to be 5 times 4, which is going to be 20. So the total area is going to be 6 plus 6 plus 2.5 plus 2.5 plus 20. And let's add all that together. That's going to get me 12 plus these two get me 5 plus 20. This gives me 17 plus 20, 37. So my total area of the pentagon would be 37 square inches. Okay, doggy. Okay. Let's keep it moving. Okay, next problem. Here it says a right rectangular prism has a length of 4.5 feet, a width of 6.5 feet, and a height of 8 feet. What's the volume of the prism? So all prisms is the area of the base times the height, or we know it as the volume being the length times the width times the height. Did I say area? I don't know. I just know that the volume of a prism, a rectangular prism, is going to be V equals LWH. So we already know our length is 4.5, and our width is 6.5, and our height is going to be 8. So I'm going to change all of these to improper fractions. So if you don't know how to change to improper fraction, you take your 4.5, you multiply your denominator times your whole number, and then you add the numerator. So this is going to be 4 times 2, you can write like this, 2 times 4 plus 1, and keep your numerator. And this would be 8 plus 1 over 2, and it's going to be 9 over 2. So this first one is going to be 9 over 2. Let's do the next one. This is 6.5, multiply, add, rewrite it as 2 times 6 plus 1 all over 2, and you get 12 plus 1 over 2, and you get 13 over 2. So you have 13 over 2, and you can change your whole number into a fraction and make it 8 over 1. So from here, it's 2 ways you can solve this problem. When I think this looks intimidating when you have to multiply 9 times 13 times 8. If you understand how to simplify your factors, I would suggest you do that first. So I would actually take this 2 and divide it into this 8, and I know that's going to get me 4. So let me use another color. I'll make this 4 and make this a 1. And just because I want to rewrite this for teaching purposes only, so I rewrite this. Now I have 9 over 2, I have 13 over 1, and then I have 4 over 1. Now I see here that I have a numerator and a denominator I can simplify again. So let me do it again. I would take this 2 and take it into this 4, and this would be a 2 here, and that becomes a 1. And so I can rewrite the problem again. So now it's 9 over 1 times 13 over 1 and 2 over 1. And this is a little less intimidating to students. And so now at this point you can just multiply everything. And because this is 6th grade math, they are not allowed to use calculators. So let's do this by hand. So let's start out with 13 times 9. So we 7, 2, and this is going to be 11. And now I need to multiply this by 2. And now I have 14, 3, 234. So the final answer would be 234 cubic feet as your final answer for the volume. Again, if you need some math help, you can text me at 407-801-9255, and I'll try to do a problem for you. If you need some help, get your free help while you can. Because folks out here, they charge a lot of money. I know, because I'm one of them. But I'm offering my services for free on Monday nights. Okay, let's look at this one here. It says, which three-dimensional figure is represented by the net. All right. You have to look for what has the same amount of faces. So a face is just, a side, a full side. So this is the face. I got 1, 2, 3, 4, 5, 6 faces. Okay, so which one has 6 faces? And it's going to be A. How many faces does B have? B has the bottom, so that's one face, and then everything around it. So this triangle, that's a face. This is a face, this triangle in the front, and there's a triangle here, and one in the back. So this one has 5 faces. So that wouldn't be an answer. So on here, I like to go over why something is not an answer as well. So this has 5 faces. Over here for part C, you have 2 faces to the side. That's 1 and 2. And then you have 3 around. So this makes 5 faces as well. Over here, you have the base, which is a face. Down here is a face. So that's 1. And then you have 3 around. You have the 2 up front. I guess it would help if I do colors. You have this one here. And then you have this one here. And then there's 1 in the back. That probably makes it, I don't know if that looks confusing or not. But there are going to be 4 faces here. Alright. Let's keep it moving. Do another problem. With this one here, it says, which 3-dimensional figure is represented by the net? Well, here, if you look, your base is going to be a square. So you're looking for something that has the bottom of a square. And this one does, part B. That's what you're looking for. And so each one of these sides come up to make your pyramid. And so it's going to be answer choice B. All right, let's keep going. Okay, now this is right here. We're venturing off into 7th grade math now. 7th grade math can be a little bit more intimidating. So it's good to have a good foundation from 6th grade and on, even before then. Knowing how to multiply fractions, divide fractions, all the good stuff that they learn in 6th grade, you're going to really need it in 7th grade because they do a lot more stuff. So let's start out here. The first question. A recipe used 2/3 cups of sugar for every 2 teaspoons of vanilla. How much sugar was used per, keyword, teaspoon of vanilla? When I see per, I know I'm doing some type of division. So let's look at here. 2/3 cups of sugar per teaspoon of vanilla divided by 2 teaspoons. So now at this point you need to know how to handle dividing fractions or dividing a whole number into a fraction. So I can rewrite this as 2/1. And now I know I need to multiply the first fraction by the reciprocal, there's that word again, reciprocal of the second fraction. So now to multiply fractions, you do 2 times 1, 3 times 2, and you're going to get 2/6. And I can simplify this fraction by dividing both my numerator and denominator by 2, and I get 1/3. So that's your answer. So it would take 1/3 cup of sugar per teaspoon of vanilla. Okay, let's keep it going. Actually, I should write it like this. It's 1/3. When they get into, students get into algebra, they have to know how to interpret the meaning of a number, especially when it comes from a word problem. So getting in the habit of telling what the final answer means will help with interpretation for later in algebra. So this is 1/3 cup per teaspoons. Or you could say 1/3 cup of sugar per teaspoon of vanilla. Alright, let's go to the next one. Okay, it says the recipe calls for 2/3 cups of sugar for every 4 teaspoons of vanilla. How much vanilla should be used for every 1 cup of sugar? So now we're doing it, we're flipping what we know. So there's like 2 ways to do this question. The first way would be the division way like I did before. So let me do it that way first and I'll show you the other. So this one would be 4 divided by 2/3. And again, you would take your whole number or your fraction and multiply it by the reciprocal of the second fraction. And this would give you 12/2, or in this case, it would be 6 teaspoons per 1 cup, or 6 teaspoons of vanilla per 1 cup of sugar. That's one method of doing this way. Or you could just kind of just really think about it. And sometimes if some kids can figure this out, this would be great. So you know that for every 2/3, you're going to need 4 teaspoons of sugar. So you can say, okay, for 2/3 cup of sugar, I need 4 teaspoons. Okay? And what you can do is like cut it in half. If I have 1/3 cup, that means I need 2 teaspoons. Well, if you know anything about wholes, like making a whole part in a whole, you'll know that 2/3 cups plus 1/3 cup gets you 1 full cup. So that's 1 full cup of sugar. So if I have 1 full cup of sugar, that means I'm going to have 6 teaspoons of vanilla. That's another way of getting your answer. So the answer here would be D, 6 teaspoons. Okay, let's keep going. All right, here's another one. It says Ethan ran 11 miles in 2 hours. What is the constant of proportionality of miles to hour? Boy, talk about intimidation. Look at this term right here. Look at that. You were like, what the heck is constant of proportionality? Okay? Who knows what that is? Well, I do. Okay? This right here is just asking, you know, what's going to be the rule every time he runs for an hour. What's going to be the rule? For every hour, what's going to be the rule? How far did he run? So basically, how far did Ethan run in 1 hour? In 1 hour, how far did he go? So, you can just divide it by 2. This would be 11 miles divided by 2 hours. And that's going to be, he'll go 5.5 miles in 1 hour. And that's it. Constant of proportionality. So if he goes, I guess like 5 miles, he would say 5.5. If he goes 5 hours, you say, well, how far does he run? You say 5.5 times 5, and you'll get how far Ethan ran in 5 hours. That's all. So this is intimidating, but knowing the proper vocabulary is important. Hopefully your teacher or whoever's teaching the course is using this particular vocabulary with you. That way when you see it on test, you won't be intimidated because you're used to hearing the proper vocabulary in your math class. Okay, let's do another problem. Kara is mixing paint. Each batch has twice as much blue paint as yellow paint. Plot points to represent the amount of blue and yellow paint used in 3 different size batches. Okay, so here's the meat of this question here. Twice as much blue paint as yellow paint. So here, if I have 2 blues, then that means I have 1 yellow. If I have 4 blues, then I have 2 yellows. If I have 6 of the blue, then I have 3 yellows. Well, you could translate that all on this graph. So let's go to the graph. If I have 2 of the blue, then I got 1 yellow. So that first ordered pair, the plot, this point here, let's do this point here. This one would be 2, 1. And so what I did was, for my ordered pairs are x, y. But you could think of this as blue, yellow. So if I wanted to do the rest of these points, it would be 4, 2 and 6, 3. And so we can plot the points, so that's what they want us to do. Erase this. Alright, so I can also do 4 and 2 and 6 and 3. And that's it. Okay, let's see here. I think I have like 1 or 2 more problems to do, then I'll call it a night. Okay, next one. It says the points on the coordinate plane show the amount of red and yellow paint in each batch. So write an equation to represent the relationship between red paint R and yellow paint Y in each batch. So let's look at our graph. It says here that for the red paint you have 2, and for the yellow paint you have 3. So that's what this order pair is. It is 2 and 3. Alright, but let's write an equation to represent this. So if I have 2 of the red, then that means I have 3 of the yellow. So instead of writing the words, you write the actual variables. So this would be 2R is equal to 3Y. And that'll work every time. So, what is the next one? This one would be 4 and 6. And this one would be 6 and 9. But, so you would just have to just keep going on with the pattern. But this is the equation. This is the only equation you would need for this particular answer. So write an equation to represent the relationship between the red paint and the yellow paint. You get 2R is equal to 3Y. Okay, let's do another one. Here it says the graph below represents the rate for the cost of the books. Write an equation to represent the cost C. So the number of books and is your X is your independent variable, and then the cost is your dependent variable. So depending on how many books you buy, that's going to be your cost. So it looks like to me, if I buy 0 books, I pay 0 money. But if I buy 1 book, and let's travel up this road here. If I buy 1 book, then I'm going to pay $5. If I buy 2 books, then I'm going to pay $10. So each book seems like it costs $5. So my equation is going to be the cost is going to be $5 per book, or 5 times B. Okay? Let's keep it moving. Oh, put a box around it because that's my final answer. Okay. I think I'm done. Am I done? Oh, no, I have another one. Okay. So it says here, an expression is shown, -5/2 plus 7 3/4. What is the value of the expression? So for this problem here, it's just 2 things you got to know. You got to know how to handle mixed numbers when you're trying to add or subtract them. And then you also got to handle integers. Okay? I'm going to actually rewrite this question. So the first thing I got to do is make sure I have the same denominator. Right now 1 is 2 and 1 is 4. So the common denominator is going to be 4. So let's take this negative 5 and 1/2 and change it so it can have the same denominator of 4. So what times 2 is going to get me 4, and that's going to be 2. So I need to multiply that 2 from my numerator and my denominator. And so this is going to be 2 here. So I know that when I am adding rational numbers, and these are rational numbers, this is a rational number. When I'm adding rational numbers and they have different signs, I'm really subtracting them. So I can rewrite this as 7 3/4 minus 5 2/4. And so it's a little bit less intimidating like this when you write it. So you're going to take your 7 minus 5, and that's going to get you 2. You take your 3 minus 2, that gets you 1. So you put it all together, you have 2 and 1/4. And that's going to be your answer. Let's go to the next problem. So for this one here, you're going to, again, these are rational numbers. Rational numbers. Okay, so it says that an expression is shown. What is the value? So you have 15.5 plus negative 16.75. Now, with this, you're going to subtract because they are different signs. So I'm going to just come over here and just do regular subtraction. So 16.75 minus 15.5. And because, even though it doesn't have a 0 here, I'm going to put 1 here. Just so you know that 1 needs to be there when you're subtracting. So 5 minus 0 is 5. This is 2 decimal, and you have your 1. Now, the problem is that you have to know your rules. Is this going to be a positive answer or a negative answer? And the answer to that question is it's going to be negative. And the reason why I know is because of my absolute value rules. So absolute value is the number that is furthest away from 0. So when you see this sign, like the 2 bars, what's the absolute value of 15.5? It's going to be 15.5 because that's how far it is from 0. What's the absolute value of 16.75 or negative 16.75? And it's going to be 16.75. So which one has the greater distance? This one here. So what was the original sign? It was negative. So that means that my answer is going to be negative. Alright. Oh, it's almost time to go. It's almost 8:30. I cannot believe I've been on here almost an hour. Okay, so this is it for tonight. Whoever tuned in or whoever came on and just watched me do some math, thank you for viewing. I'm on every Monday night. If you or your child needs help in math, they can text me at 407-801-9255, offering my services for free. I know there's a lot of people out there that need help with math, and I am here to serve. So, until next time, I'll see you guys next Monday night. So, ta-ta for now.